In this video, we're going to look at Explain 2 from topic 4.3. So we are solving real-world problem solving using a simple quadratic equation. So two commonly used quadratic models for falling object near Earth's surface are the following. Distance fallen in feet at time t seconds is given by d of t equals 16t squared. And the height in feet at time t in seconds is h of t equals h sub 0, which is usually an initial height, and then minus 16t squared, where h of 0 is the object's initial height in feet. For both models, time is measured from the instant that the body begins, the instant that the object begins to fall. A negative value of t would represent the time before the object began falling. So negative values of t are excluded from the domains of these functions. So we exclude negative. Okay. This means that for any equation of the form d of t equals c or h of t equals c, where c is a constant, a negative should be rejected. So if we get a negative answer, we're going to reject it. So we're going to, in example 2 here, we're going to write and solve an equation to answer the question. Give the exact answer, and if it's irrational, a decimal approximation. We can go to I have the answer to the nearest tenth. We can do, I would prefer you go 3 decimal places. Your book is saying to do one. So if you drop a water balloon, how long does it take to fall 4 feet? So we need to determine if that is distance or height. So this would be just a distance equation because it's not talking about the height of the water balloon. So we're going to use the model 16t squared. We want to solve for t. We know that the distance that we have is 4 feet, so we're just going to set it equal to 4. Let's go ahead and solve that. So I'm going to divide both sides by 16. So we would have t squared equals 4 over 16. Which if I wanted to, I could reduce that to 1/4 because 4 divides both 4 and 16. I'm going to undo the square by taking the square root of both sides. And when I take the square root of both sides, I have to do a plus minus. And then I know the square root of 1 is 1 and the square root of 4 is 2. Now, I do have a negative answer here, and I said that we needed to reject that because it doesn't make sense to go in negative time. So we would just conclude by saying the water balloon falls 4 feet, which was our original amount of falling, in 1/2 a second. Let's take a look at part B. The rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon dropped from the rooftop to pass by the 3rd-story window at 24 feet? So now we're actually dealing with a height. So this is an initial height. They're wanting us to figure out something from a height of 24 feet. So we're going to use the second equation, which was in height. So we're going to be using h of t equals h sub 0 minus 16t squared. Remember, we have that initial height. So let me just write that here. H of t equals h sub 0 minus 16t squared. So the height our initial height was that we were at 50 feet. And then they want to know the time it takes us to get to the 24 feet. So I'm just going to set the equation equal to 24. Let's go ahead and solve that. So I'm going to ignore that I had the h of t in front. I'm going to subtract 50 from both sides. So negative 16t squared equals negative 26. I'm going to divide by the 16. That's going to go positive. And then I'm going to take the square root of both sides. And always do a plus minus out front. So t equals plus or minus the square root of 26, which I cannot break down, and the square root of 16 is 4. So my time, we would reject the negative. We would say that it takes the balloon passes the 3rd-story window at t equals the square root of 26 over 4 seconds. If I were to put that in my calculator and get the decimal point, it would be 1.3 seconds. And then we have this reflect question. So explain how the model h of t equals h sub 0 minus 16t squared is built from the model d of t equals 16t squared. So what we have to do is we got to think of h of t is the object's height, the falling object height at t seconds. So that's what the h of t is. As the distance that the object has left to fall. So as the distance the object has left to fall. So the total distance of the fall is h sub 0. Okay, so our total distance that we have to fall would be our initial height. So h of t is what's left. So h sub 0 is total distance of fall h of t is the distance left over after subtracting the distance already fallen, which is the d of t.